Hi, welcome back. Today we're going to talk about derivatives of trigonometrics, which is section 3.5. And really, there's a lot of trigonometrics that we may possibly have to take the derivative of. But one of the main ones that we should focus on is the sine family of functions. So we've got sine of x. And the interesting thing about sine is that it's cyclic. So in other words, if I want to draw my sine function, it starts at 0, it goes up to 1, it goes back down to -1, and then it goes back to 0. Well, you'll notice that right here, that the slope of this is about 1 to 1. Rise over run is about 1 to 1. So that would mean that the derivative of sine would have a value of 1 when x is 0. And as you can see, sine peaks at pi halves, then it goes back to 0 at pi, and then it has its negative peak at 3 pi halves, and then finally ends its cycle at 2 pi. Alright, so we've decided that the slope of the sine function at x equals 0 must be 1. Now you'll notice that when we get to the top of the sine function, the tangent is flat, which means a slope of 0. So that also means that our derivative of sine must be 0, because the slope at pi halves for sine is 0, therefore the derivative of sine at pi halves must be 0. And then likewise, you'll notice that when we get to pi, sine appears to have a negative 1 to 1 slope, which means that when you plug in pi to sine, you get a negative 1 slope. Therefore, the derivative of sine at pi must be negative 1. And you'll start noticing a trend. Once again, the slope down here is 0. And what you'll find is once you mark some points, that it kind of pops out that the derivative of sine is the cosine graph. So this starts the beginning of our cycle as sine. So when I write d dx, I mean taking the derivative with respect to x of sine, and it points in the arrow direction, is equal to cosine of x. And you could walk through this process for the next part of the cycle, but I just wanted to show graphically what's going on here. So the next step is what is the derivative with respect to x of cosine of x. And that happens to be negative sine of x. And the derivative with respect to x of negative sine of x is negative cosine of x. And the derivative with respect to x of negative cosine of x is sine of x. So this is kind of this cycle of sines and cosines. And so whenever you see sine or cosine, to find the derivative, just reference this chart and or memorize it. So in other words, I just always think, well, we start at sine. Its derivative is cosine. Its derivative is now negative sine. Its derivative is negative cosine, and negative cosine's derivative is sine. Once you do it enough times, this will be ingrained in your memory. So that's the cycle of sines and cosines. Another really important one is that the derivative with respect to x of tan of x, tangent of x, is equal to secant squared of x. This is one that most people just choose to memorize, but I'd like to show right now a technique you could use just knowing a few of the derivative rules for trigonometrics and the basic rules that we covered already. So I could write tangent of x as sine over cosine, because tangent is equal to sine over cosine. That's a trigonometric identity. So sine x over cosine x. Now we have two terms that involve x, one on top of the fraction, one in the denominator. This means we should probably use the quotient rule. So the quotient rule goes low, d high, so cosine d dx sine x, minus high, which is sine x, d low, which is the derivative with respect to x of cosine of x, all over low squared, cosine squared x, which I'd just like to point out that cosine squared x is equivalent to cosine of x squared. It's just a more condensed way to write it. So now we've used the quotient rule, which is low d high minus high d low, all over low squared, to find our derivative of whatever function this is. Now we just need to do some of the smaller derivatives. The derivative of x, the derivative with respect to x of sine, remember our little wheel, is cosine. So what we have here is cosine x times cosine x, because the derivative of sine of x with respect to x is cosine x, minus sine of x. The derivative with respect to x of cosine of x is negative sine of x. So this is times negative sine of x, all over cosine squared x. I'm going to make some room. Alright, so now what we're going to do is simplify. We've got cosine x times cosine x. That's going to be cosine squared x, because there's two of them multiplied together. Minus sine x times minus sine x is positive sine squared x. And all this is over cosine squared x. Now that we're at this point, we can we can split the fraction into two parts. And this right here, sine over cosine, sine squared over cosine, that's tangent squared as well. So it's sine squared over cosine squared. Using this same identity here is tangent squared x. Cosine of cosine squared x over cosine squared x is the same thing. So what we're left with is 1 plus tangent squared x. Now, this doesn't quite look like secant squared of x, but using the Pythagorean identity of trigonometrics, we can prove that it is. And how we're going to do that is we're going to remember that when we look at the unit circle, we have the hypotenuse of length 1. The x direction is representative of cosine of x. The y direction is representative of sine of x. This is a right triangle. So using Pythagorean's theorem, we can say that sine squared x plus cosine squared x must equal 1. Now we can go ahead and divide everything in this expression by cosine squared x. We're going to divide it by cosine squared x, every term. And what we end up with is tangent squared x plus 1 equals 1 over cosine squared x. Well, 1 over cosine is secant. So 1 over cosine squared is secant squared of x. And what you'll notice here is 1 plus tan squared x equals secant squared x. And so right here we can write that this is equivalent to secant squared x. Thus, we just proved directly that this is true. Now, you may not want to do that derivation every time. It's much easier just to remember that the derivative of tangent of x is secant squared x. But these kind of methods are very important to know for when tricky trigonometric problems pop up. So if you are a little bit rusty on your trig, as most of us are, I recommend having a trig identity sheet that you just find online, some trig identity sheet to help remind you what you can do with trigonometric functions, and that should get you well on your way. So we were able to solve this just using the quotient rule and a knowledge that the derivative of sine of x is cosine, derivative of cosine x is negative sine x, derivative of negative sine x is negative cosine x, and the derivative of negative cosine x brings us back to sine x. So once again, put that down on a sheet of paper. Once you do it a dozen times, you'll remember it. I hope this was helpful, and I'll see you next video.